So today we're going to dive into a tool called Harpoon. And look, this isn't just a breakdown of where it is right now. We're going to go a step further and actually draw up a complete blueprint for its future. Think of this as a roadmap for unlocking its true potential.
All right, so here's our game plan for today. We're going to start by looking at where Harpoon is right now. Then we'll get our hands dirty upgrading the training engine, tackling its constraint problems, and figuring out smarter ways to sample data. And to wrap it all up, we'll talk about building a much stronger foundation for the whole thing. Let's get right into it.
All right, kicking things off with Section 1. Where does Harpoon stand today? I mean, you can't really draw a map to the future if you don't know your starting point, right? So let's establish a solid baseline and take a peek under the hood to see how this thing actually ticks. Okay, so if you take a look at the architecture, you'll see it's based on something called diffputer, which is a diffusion model for tabular data. But honestly, that's not the most interesting part for what we're doing today. What you really need to focus on are two specific details here. First, see that? The training epochs are set to just 200. And second, it can only handle a single constraint per call. Now, keep those 2 points locked in your mind. They are absolutely crucial for everything we're about to talk about.
And here they are, the 5 key files where all the magic really happens. You've got the Python wrapper that kicks everything off, the training script, the whole shebang. You know, understanding this file structure is the first step, because it shows us exactly where we can go and make some really smart, targeted changes.
Okay, now it's time to get into our first major upgrade, the training engine itself. This is where we find, the low-hanging fruit. We're talking about the simplest changes that can give us a massive boost in the quality of the results.
So, let's just ask the obvious question. If we want better results, where do we even begin? What's the absolute simplest, most direct path to getting there? And boom, this slide basically says it all. On the left, you see what we have now, the current implementation, chugging along for just 200 epochs. But over on the right, that's what the original research paper recommends, a full 1,000 epochs. We're not talking about a small tweak here. That is a massive difference.
So here's the bottom line. Just by aligning with the original recommendation, we're looking at a 5-fold increase in training time. This isn't some complex architectural overhaul. It's one simple change that could fundamentally unlock a whole new level of quality, not just in the data it generates, but in how well it actually follows our instructions.
And honestly, we don't even have to stop there. If we wanted to get a bit more advanced, we could bring in something called classifier-free guidance, or CFG. All that really does is it teaches the model to pay way more attention to the constraints we give it, which naturally leads to better results. Another really smart idea is using what are called equal frequency ordinal bins. It's a fancy term, but it just means we make sure the model learns to represent the rare weird values just as well as the super common ones. It's a great way to avoid bias in your data.
All right, next up, we're going to tackle one of Harpoon's biggest Achilles heels right now, how it handles constraints. It's really time to move this thing beyond just following one simple instruction at a time.
So here's the core of the problem, plain and simple. Right now, Harpoon can only handle one column equals value constraint per call. That means you can tell it, make the country USA, sure, but you can't tell it, make the country USA and make the city New York. And that right there is a huge limitation on how useful it can be in the real world.
But here's the silver lining. This is a massive opportunity. The fix, at least in concept, is pretty straightforward. All we really need to do is update the sampling script so it can accept multiple call equals val pairs. That's it. We do that, we unlock multi-constraint support, and this tool becomes way more powerful.
All right, on to Section 4, smarter, faster sampling. Now this is where we get to be really clever, because we're going to look at fixes that don't require any changes to the source code at all.
Check this out. It's a framework called Reject and Resample. It's so elegant. Step 1, you just generate double the samples you actually need. Step 2, you filter those results, keeping only the rows that perfectly match your constraint. And then, Step 3, you just trim that filtered list down to the final count you want it. You get way better results, and you never even had to touch the core model.
Here's another approach for you. Post hoc repair. The idea is super simple. For any rows that come back and fail the constraint, you just fix them. You literally overwrite the column with the value you wanted. Now, you got to be a little careful, but for categorical columns that don't have a bunch of complex dependencies, this is a totally safe and really fast fix.
Okay, for our final section, we're going to zoom out a little bit. We're moving away from the algorithms and focusing on the architecture itself. It's time to talk about building a truly robust foundation, and that means fixing some pretty big weak points. And this quote here, it comes directly from the source material, and it does not pull any punches. This is fragile. Race conditions clean up on failure. See, this isn't about making the model a little bit better. This is about the whole system being unstable and unreliable. It's an architectural problem.
So what is this fragile pattern? Well, it's been called the self-destructing script pattern, and honestly, that's a pretty good name for it. It's basically a ticking time bomb for stability. What happens is, the code writes a temporary script, runs it, then deletes it. If anything goes wrong in that chain of events, things can get real messy, real fast. So what's the fix? Well, it's actually just to refactor it into a stable library call. Instead of this wild temporary script pattern, you treat Harpoon like a professional piece of software, a library you can import and call directly. It's just cleaner, safer, and way more robust.
So, let's just quickly recap the blueprint we've laid out. Number 1, crank up those training epochs for an easy, massive quality boost. Number 2, evolve beyond handling just one constraint at a time. Number 3, implement those smarter sampling fixes at the wrapper level. And finally, number 4, get rid of that fragile script pattern and refactor it to a stable library call.
And there you have it. That is the blueprint for a better Harpoon. It's clear, it's actionable, and it covers all the bases. The only real question left is, who's going to be the one to build it?